Okay, this is Durward King with Samson Community College. This is ELC 215, electrical maintenance for automation systems, and it is February 23rd, 2021. And we're going to finish up one question on Station 6, and then we're going to get into how to set the IP address on laptops, set up communication driver, and begin to go online with the machines and view the logic as they run and begin troubleshooting. So I'm going to flip over to a question that we did not answer the other night. Okay, there was a question here about the voltage output of the fiber optic module. There was a fiber optic module that detects when there's a screw down in the hole and when there's not. And so it wanted to know what's the voltage coming out of the fiber optic module without a screw and then with the screw. And so the schematic is here. Let's see, where did my diagram get to? Well, let me pull the schematic back up again here, because I think I lost it. I did lose it. So on the schematic for for Station 6, there was one fiber optic sensor there. I'm going to zoom in on that. Okay, so that's it on the screen there. Let me make sure I've got my share right here for whoever's out there. When I change screens, I have to resync it with a screen share, or else they don't see it. The Zoom does not follow. It does not follow what I do. I have to tell it what to show. So this is the same symbol as it was used on Station 5 for a photoelectric sensor that has a beam that shoots out and bounces back off of those caps. Now this same symbol here that shows a light going out and a light coming back and has a 24 volt coming in and then a signal leaving going to the PLC, it says for screw presence. Now the question on your sheet is, what is the voltage leaving that module without a screw? And we saw the other night that without a screw, there was no signal going to the PLC. That's going to be 0 volt. Okay, just save us some time. With a screw, you got a light going to the PLC on this particular input. The fiber optic shines through a block like this. There's a hose, there's a fiber optic line going into the block, and then there's a pickup line on the other end of that small block over there. So it's a two-piece thing, and if the beam makes it across, then that module is set on dark operation. You remember light and dark operation that we talked about? That module's got a switch that says L and D. And if you switch it on D for dark, here's what it does. When the beam is blocked, and it doesn't see the beam coming back, it's dark, and it puts 24 volts to the PLC. 24 volts comes out of it if there's a screw in there and it blocks the light. That's called dark operation. So if you take the screw out and the light does get through it, that's light operation, then there's no voltage going to the PLC at that point because of the mode that we put it in. If you look on the front of that module, there's a little cover and it opens up and there's a switch. If you look bigger, it's got the I don't know if you have time to watch the video. It's ticking twice as fast as I wish it was. Okay, everybody got that? So that would be going to that question right there. Okay, everybody cool? That's the question there. Do you have a lab sheet, Victor? Have you got a sheet for 6? Okay. There's other ones in here that I know you don't have. I won't take time to tell anybody what they ain't turned in. We're just gonna roll because this time's gonna be gone for you know. We ain't got an hour and a half. Anyhow, we ran the station. Seemed like there might be one more question there. We skipped them. Yeah, one more question there. Why is the stop button on the control panel a normally closed contact? Why do you think it would be normally closed? So when you press it, it opens up and it disrupts the cycle. Exactly. When you let go of it, it's closed and it lets the machine run, and then you have to hit it to disrupt it. That's a good way to put it. Yeah, and that finishes up station 6 as far as that sheet, your lab paper.
I don't have no questions that you want to check to see.
Right. You can just, you can catch up on that later. We're gonna roll now. So back to now, if you look on the screen there, you've got the PLCs. There are 6 PLCs in the system, and they have an address of 130.130.130. And after the first 3 sets in the address, the last section is a .1 through a .6. Now, those are the PLCs that are on the front of the machine. So when you look directly at a station, you'll see the PLC looking right at it. The Ethernet port that goes into that PLC, that is the address. That's like your house address at home in your neighborhood. You have an address that's different from your neighbor, right? And so now, behind each station, there is a remote I/O chassis back there with a module with Ethernet jack on it that lets you have remote input/output cards. The address for the Ethernet remote I/O unit behind each station for station 1 is a .13 through .19 for each station. So this is the address of each remote I/O unit that's behind the machine. It's under the top cover behind there. And if you look behind there, you'll see some green lights, and that is the remote I/O address for that Ethernet adapter. Okay. They skipped 17 because we had one station that we're missing, and I've asked for it recently. It's station 7 for a warehouse, and if we get it, it's got servos on it, Allen Bradley servos and stuff, and I hope we get it. Now, the laptop computers that you're using, they have to have an IP address also to be able to communicate on the network, to see the programs running, to upload from the PLC and save a copy or download a new version to it, to have this communication. Your laptop has to have an address, a definite address called a static IP address. Static is compared to dynamic. Now, dynamic addressing is where if you're going to be on the internet and you've got an Ethernet cable and you're on the internet, you got to have your address set up as automatic addressing, so that the server that you're connected to gives you an IP address. It gives to you. Yeah, it leases it to you for a certain amount of time. You ain't paying, but they call it leasing. So it'll give you one for a while, and then the next day or two, when you go back on, may be different. So So anyway, in this system, it's a sub network called a sub network, and it's private. So you got to have static IP addresses that don't change. That they have to be definite addresses, and then another thing you have to have, that everybody in the neighborhood has to have the same mask on, the same sub network mask. So there's a lot that could be said about that. If I were to convert that into a binary code there and explain the breakdown of what it means, it's a type of a filter. It's a set of numbers. It's a filter, and that's all you want to know right now. You can look at it sort of in a kind of in a funny sense and say that everybody's got to have the same mask on to get into the parties. For instance, I'm just going to say that just in a funny way, you got to have the same mask on to get in the network. Okay. It's like a gate in a gated community. It is. Okay. That's another way to put it. So those two things, you got to have your unique IP address, but you got to have the same mask as everybody else. Okay. That's kind of what you have to have. And so now we're going to look at how do you actually set that on the laptop. So has everybody got their laptop turned on, and do you see your desktop with your icons? Everybody see their desktop? Okay. Just remember that the password is, the username is PLC, and then there is no password. Okay. And so if you take the paper that I gave you, and for those of you that are out there watching, I'm just going to show you what the paper looks like. So this particular paper here, everybody got that? Does everybody have their copy of that? Yeah. Okay. So I'm not going to show this while I'm doing it, because you hold the paper in your hand, and we're just going to physically do that while you can use this as a reference. Okay. So stop share, and let's go. Huh? Right. Just you hold on. We got to stay in step together. Now let's make sure that, let me go back out and get my Zoom synced again. Okay, so I got it where somebody out there can see my okay. Everybody look closely here. So step one is you want to go down in there to the start menu and hit that. Everybody do it at the same time. Yeah, everybody listening. Please, let's do it at the same time, because I'm going to ask you to do something. I'm going to come see, did you do it? And then I'm going to ask you to do something else. I'm going to come back and see, is it done? I got to see you clear some stuff, see it gone, and then I'm going to see you put it back in. So you want to go down there, your start menu like this. Now I've got Windows 10, so you probably don't see that come up. You got to get the control panel. You want to get the control panel. What? Well, where are you at right now? That's fine. Just let us catch up to where you are. Yeah, just stay right there. Just stay right there. Don't go nowhere. Don't go nowhere. Now for me, I'm having to hit control panel. I mean, again, the appearance of yours is different because I've got Windows 10, you got Windows 7. And so at this point, you want to go under View Network Status and Task. Now, your screen may look different because I've got Windows 10. Don't let that worry you. I've asked for Windows 10 machines, and they're working on it. They're working on it, okay? network status and task. After that, you would go into change adapter settings. And then on mine, what I see next is mine shows Ethernet. Now yours may not look this way, but on mine, I'm going to have to right click on Ethernet, local area network. It's exactly right. You can right click on that and hit properties. And when you get, is everybody at that point there to where they can see that? Then you want to go into Internet Protocol version 4. Be careful what you do now, super careful, real careful. You click version 4, and then you want to hit properties. And then on mine, I've already clicked obtain the address automatically. I want you to click it automatically. Click it, and it's going to get rid of whatever may be in there. Go to automatic. Okay, did you do yours? Does it say, did it wipe out the addresses? Okay. So it wiped them out. You got rid of yours? Yeah. Okay. Just remember, if you tell the time that I bring it all around, then that will take when you go up to the big goes over the internet, you'll be sure to get on the actual internet. But if you say, give me the rest all that. We don't have to be. They use that like where he works at, like this, there's an engineer can see access to the home. Yeah, they're trying to yeah, they do. We got some robots over there, 5 regular part-time, yeah, they don't even use they're using series. He said he likes that. I don't know. Yeah, well, I like it. I like Adam Brown too. More of the user too. But he said he likes series. Adam Brown is more using I can't wait now. So, did you guys keep you got the right address in? Oh, you want that? I think let's do one in yet. Yeah. It is 5. Yeah, got one other thing. You just have to add the 37. Anything else? Hold on. Yeah, we don't keep that. We're not trying to get out of here. They're going remote like somebody access and how they're not doing that. Yeah, okay. But like if you're planning, all these addresses they have to be, they're going to be met with the internet, but somebody knows what they are. Someone knows if maybe you remember that, I don't know. But somebody in that plant should know all your addresses. And get the code. Okay, now, everybody did good. Now let me set mine. Okay. Okay, so now, is everybody comfortable with what you just saw there? Yeah. Now, Joel, you need to get, is there another computer? Yeah, but he just did it. Back out and let him do it. Yeah. You got to physically do this. And yeah. And we got to get you some gloves. Yes. I went all around, so you don't have to come home. I went by and said somebody else. Thank you, man. I'm shooting 100% people here, man. Okay. So now, if you flip over on your paper to how to set up RS Links Classic. So let me get back up to the desktop again. Let me see, what am I sharing right now? Yeah, I'm sharing the right thing. For whoever's watching, if McGill or somebody's out there watching, let's see who is not here. I got to go here.
I haven't seen it.
There's one right here.
Now you see it.
There and here. McGill's not here. So we're missing 3 people. Okay? Which means it's worth recording. If you're missing one, it's worth recording. If they'll watch it. That's another, yeah.
Unless we're just missing there.
Yeah, and we know he probably ain't gonna watch it. He probably ain't gonna watch it. Okay. Anyway, so look, let's get this here out of the way. Now, everybody pay close attention. Listen good. Everybody listen good. There are two software packages you have to use if you're going to go online with ELC. 2 software packages. The first one is called RS Links Classic. This phone on my screen there, it shows a picture of a computer and a ELC with a chain link. Is that what you see on your screen? RS Links Classic. Oh, yeah. So does everybody see that? Yeah. That's right. So if you might be thinking, what is RS Links Classic? It's a communication program that it sets up a link, as the icon shows it, it's a chain link between the PLC and the laptop. So it sets up a communication power link, and it acts like Verizon does with your cell phone or USB. When you got the camera and you talk to your service back and forth to somebody, and they sort of convey your message back and forth. They don't talk for you, but they convey what you say, right? It lets you talk to someone and back and forth. That's what RS Links gives to this. It sets up a highway to communicate. That's all it is. That's what you're right about. So you have to configure it for whatever kind of cable you're using. Is it in the bottom line? So you got to get your cable, so you got to get it right. If you get your serial cable, like on some old PLCs, you got to have a serial driver. If you're using a USB connection, you use USB on this on certain types. There's a USB port on the front. The USB port that is used, you've got one PLC that has to be configured off. And then with USB, that's a special driver there. It's another driver. The driver can get the drivers in the links, RS links. And it's all based on what kind of cable you can plug in and communicate. That's a simple step to it. So you go in Links, you go in RS Links Classic. And by the way, that RS Links, it works whether you're using the old Allen Bradley PLCs or the new ones. It's the same communication program. Man, let me make sure that I'm sharing here with okay, so does everybody have their screen that looks something kind of like this? If you do, raise your hand. If you're sitting where I'm at. Let's give Joel just a second here to get him called up. Where are you guys at right now? What point are y'all at? Okay, good. So did you clear it? Yeah, you cleared it. Okay, good. Joel's a fast woman. He's going to catch up real quick. We're not going to leave him behind. Joel has come back after a couple of years out to try to finish the degree, and we want him to finish. Hey, if one of y'all grab, there's a block that fell on that manhole, man. There's a cat. Can y'all get that stuff to fail? Watch your hands there. Yeah, I just noticing that. Man. I know when it happened too. I heard something the other day before we were ball. That screwdriver come up and it got hung in the screw head, and that block come up, and I heard something tumble, and I just didn't see the whole thing. There's where it is. Yeah. Okay. So where y'all at now? You're in Links, so you're up with us now. Now what's close here? Do you see a driver in? Here's going to show drivers that have been installed. Now this here says Ethernet Ethernet, does yours say Ethernet on it or not?
Yes.
Now, so here's what we want to do. The third icon, hover your mouse over the icon and see what does it say. What, if you put your mouse over it, what does it say? Configure drivers, the third icon. You hit the third icon, it's a picture of a cable, isn't it? It's a picture of a cable. You go in there and it shows you whatever driver is installed and running. Now here's what we're going to do. I want you to hit stop and delete. I want you to get rid of the driver. Stop and delete and get rid of the driver. So we're starting with no driver. Okay, did y'all get through y'all's little bit? And let's go, which one we delete? The Ethernet driver. So did your driver go away? Did yours go away? Now listen carefully. Don't miss this. You go under available driver types. Now when we deleted it, it only got rid of the active driver. It didn't wipe it out. It only said we're not going to use it. It's still in the background, usable. Go under driver types, available, and look, there's a list. There's a list of drivers. I know my screen is small. I need to adjust the resolution and make it bigger. But look, there's different drivers in there. Now, if you don't know over ELC, like the one that we see on the left, this is the upper half rated ELC. It's a split file of anywhere on that. Now, the driver for that cable is serial cable, not Ethernet serial. Now, if I were to use that, it would actually be RS-232 to the EF1 drive. That's the only one's going to work on that particular cable. You got to choose that driver and then do the configure on it. Now, for Ethernet, there's two drivers. The one we're going to use is called Ethernet IP driver, and the IP in this case means industrial protocol. Now, that particular driver is what you use to communicate with PLCs and the remote IO. The other Ethernet driver just says Ethernet devices. That's the one that you use if you're going to program a panel in touchscreen. That's the one that you use to set one up, create the program. It's the one Ethernet driver, not the IP driver. And you say, what's the difference? Well, I went to the schools from Rockwell. Here's what the guy told me. That the IP driver, the Ethernet IP driver, what it does is it'll populate the page. It'll go out to one to find all the addresses in the network. It'll populate the page automatically, show you what's happening in the network. It will. Whenever you go to that driver, it'll show you everything that's good. The other driver will not do that. This driver, the one that says Ethernet devices, you got to go to the management for it. It doesn't populate the list for you. You got to go somewhere like silver. That's what that has to do. And that's what is used on these touchscreens to set those up initially. Okay, so if there's other drivers in there for other types of cables, there's a virtual background driver that's used for like simulation software. And there's other drivers that we're not going to use, smart cards and other things. Somewhere down the road, the bigger thing that you use in the train, I don't know, or you use any other drivers other than Ethernet.
The ones I use, the Ethernet are
They already should put it to USB, right? That's what we're doing here. But other than that, the USB right here, that USB driver, that's one right here for USB. So in here, you're only going to be working on that three drivers. Okay, but if you've got some other types of equipment, special stuff, they got some special drivers in there that we're not going to use in here. So you choose the Ethernet IP driver and hit add move. And this is the default name for the driver. You could rename it, but there's no point in doing that. So you leave that name as it is and you hit OK. And then after that, you choose Windows default for this setting. And you choose browse the local subnet. Browse the local subnet. This is a local subnetwork. And then you hit OK. And if yours says that it's running, raise your hand. Okay? Is y'all's driver running? Dylan and Luke, is your driver running? Yeah, and then browse local subnet. Does it say the driver's running? Now we're gonna open the driver and let it populate the list and show you everything that it sees in the system. But we got a problem that the power's not on any of these, so it's not gonna see anything yet. So we gotta cut everything. Let's cut all the stations on. Yeah, cut all the switches on. When the conveyor starts turning, you'll know it's fully booted up and it's communicating when you see the conveyor come on. That's automatic thing. That's the first thing it does by itself. See, right now, until every one of them power up, you're not going to see all the addresses through the system because those Ethernet tables, they're all daisy chained. The PLCs have two Ethernet jacks on them. The remote I/O has double jacks. So what they do is the first PLC has a free port. We take that free port and we go to an 8-port switch over here to bring our laptops in. So all these laptops around the room, they're strung in, going in through the 8-port switch. That 8-port switch goes with one cable into the free jack on the first PLC. Then after that point, the second jack on that PLC goes to remote I/O, and that second jack comes over here, and it daisy chains around, and every jack is occupied except there's one free on the last one. There's a free jack on the last one, and it would go to station 7. When we get station 7 down the road, it's got a warehouse and servos and stuff on it when we get it. So if you lose power on one station, somebody gets e-stop, everybody downstream is not going to be able to see their watch, you know what I mean? Because you will lose power from their downstream, therefore the network's going to be dead from there on main, you know what I mean? Because they're using the daisy chain jack way of having everything connected. So you've got to have power on everything to see all the IP. So everything, all the bits running. So now look, watch carefully. Yours is running, hit close, and then there's a plus symbol on the driver itself. You hit plus, and that will open the driver. And you should see it should populate the list and show you all 6 PLCs, and then the remote IOs have a yellow question mark on them. The yellow question mark means it's just some other brand. It's not Allen Bradley. It's a German brand remote IO called Weidmuller, and it says unrecognized device, but yet there's a part number there. It actually does recognize it, but it's not an Allen Bradley device, so that's why the question mark is there. But it communicates fine. It's been set up properly with parameters to make it talk with Allen Bradley. But you see the 130.1, and then it says the .2, 3, 4, 5, and 6. Those are the PLCs. Is those 5 and this 5 and this 1. Then all the remote IOs are the yellow ones, the 6 yellow ones. Do y'all see that? Does everybody see all those addresses? You see all of them? Okay. How about Eric and Michelle? Do y'all see all those addresses? So you don't see any red X's in there, do you? No. Okay. If you ever see any red X's, then that means that it wants to see those addresses, but it's not able to see them, which could mean that somebody hit an e-stop halfway and then you've lost half the network. That could be an indication of that. Everybody good so far? So now I'm gonna tell you, like, there's a plant down in Rayford called Unilever, And they got hundreds of PLCs, hundreds of drives and stuff, hundreds of drives, BFD drives, bunches of PL. They got networks that are so huge they got more than one network in the plant. Unilever, and they make stick deodorants and body wash. I talked down there a few years ago at night for about a year. Man, yeah, they got a nice plant, real nice. And
Did it smell good?
yes, it did. You could be on the edge of town coming in, man. It smelled like the whole town smelled like deodorant, man. It smelled like I ain't kidding. It smelled good, did I ain't kidding. But that list when it populated in that plant, man, it went. It just went. You know, it was huge list that showed you lots and lots and lots of machines, PLCs and stuff. And anyway, so this is a small list compared to some places, just small. Next thing is you can go over here and hit minimize, and you can just keep links running in the background. And then the next step is going to be to click on. Now let me explain. There's when you go looking at the you just set up the communication RS links. The second software you're going to look at is the actual PLC software that lets you create programs or go to view existing programs while they're running, do uploads to save them, and download new versions and stuff like that. It lets you see the actual level of now, I'm going to write down some names here of the possible software that you have to use. On older PLCs, it was called Office Logic 5000. Now, on the newer software, it's called Studio 5000. Both of these are essentially the same thing, and the difference is they call it RS Logic 5000 up to version 21. When you got up to version 21, they changed it. Let's say version 20. When they got to version 21, and now it's called Studio 5000. So if you go in a plant like a big, you got some stuff in there, right? Okay. So if he's on a PLC that has firmware is like operating system. It's how Windows is in the laptop. So the operating system in the PLC is called firmware. If you got firmware that say version 20 or older, and the software you got on the laptop is going to be called RS Logic 5000. You got to have the version that matches the visual of the program. So, in all your refrigeration, you're going to use the version 17. Version 17 is old. It's got RS Logic 5000 version 17. So, if you go down there, you got to have version 17 on that laptop. This system is version 21.03. Okay, so it is going to be a 5000. And then last some of those you could class we use version 2. On the version. And I have some PLCs that are before you come on like on this board here. But it's the same kind of PLC that is in this system. And these can be upgraded, they can be reflashed up to version 2. So even if they're not 21 out, they can be reflashed. The flash again, they're holding the operating system. You can reflash them in and put version 22 in them. And we're not going to do all that right now, but I'll let you reflash on these, okay? Because what I'm going to do, when they're brand new, they don't have any software in it. They just send them out. You got to put one there. You choose what version you want. It's going to match your system in that plant. And then you put it in there, and then you go to your electrical box. Anyway, so that's the possibility on software. Like on the screen, you see RS Logic 5000. You see that? That's the older software. And you also have on you see how you got the older stuff on here, okay? And then The newer one is called, it's just like that. It's a blue glow, and that's the one we're going to use. Okay? So you're going to select that because we're on version 21 up. Oh, what you do? You move the camera? Okay, but that was nice. Thank you. Now I've already got mine pulled up in the background. I can click. So when you pull up the software, you want to go under. You want to go under open. Now my screen is everything is so small. If you go to the first icon that says open, it's like a middle folder, and you hit open. Studio 5000, right? Studio 5000, yeah. Your screen is looking different from mine. That's okay. Go in existing programs. If you got the blue screen, you're seeing the blue screen pop up. You go into existing programs. Yeah, existing projects, yeah. Y'all see that? Existing projects. Do you see 6 programs in there? 6. Yeah. Now, these are the actual analog programs that run the machine. This ain't firmware, but this is the actual logic lines ladder logic lines that run each machine. The 201 is for station 1, and it goes to 206. So I want everybody to go online to 201 because we're gonna step through and let you make sure you can step through the bottom of something as a proof. So I'm going to go under open. And you should see those 6 programs there. The FMS 201, it is the program for station 1. And then next, if you look over here in the left side of the screen, still loading. Okay. When you see this screen here, give me a sign. Okay, now. If you see where it says body and control body, and body, what that represents is it represents the block that the product that runs through it, which is the body of the product. That's called the body right there. Okay, and that's what it uses of the mechanism. Now, no matter what kind of machine you go up to, it gets used to Studio 5000. Most of your logic is going to be the same. Well, let's say this. Your logic is going to be under something called task. It's going to be under task mode. Now, under task, you can have a continuous task, and there's other kinds of tasks. You can have periodic tasks, you can have event-trigger tasks. We only have a continuous task in this machine. Under continuous, you go in here, this folder, and you hit the plus symbol, and it will open up the continuous task and show you all of the programming that's included on that one station. So you hit the plus symbol. And what you see now is, did you see this where it says training, columns IO, columns ELC, and so on, output step, and so on? You see that? Everybody else see that? And I'm working on now, I'll probably like later on. It is. I'm at work. I have to call you later. I'm working. Go for it. If you want to call back, say about 9 o'clock, I can talk to you then.
Okay, I'll do that. All right. Now, so look, when you look up that, this English man, here's what you've got. You've got a main lateral logic program, and you have subroutines that are actually called from that main routine. Most of the logic that each one of these lateral logic subroutines, there is logic that does a particular thing on that one station. They've got that logic divided up in subroutines to organize and make it easy to find certain things because of those calculus. Most of the logic on that station could be in a subroutine called steps. But that's not the only place you're going to find logic on that station. Just start having a subroutine called steps. All these subroutines are actually turned on by the main routine. You're going to get that right now, but that main routine, what it does is it runs a machine. And that main routine turns on all these other subroutines in that one station that have a particular task of logic per subroutine. So you've got a main logic program here, and then you've got subroutines that are called from that. Let's go to the step. Let's go to the steps.
You'll see the other routines soon enough, but steps is where the main stuff is. So if you see some contacts and some lines that look like that, raise your hand. So you're looking at if you want to see it larger, if you want to see the fonts get bigger, here's what you can do. You know how small that is? You can click out here with your mouse one time, just out here somewhere, and then hit the plus symbol, and it will make that logic get bigger. What I call the Reader's Digest version. It makes it get big, you can read it better. So what do you see right here? What does that say? Somebody read that. Of the graph set. Does that sound familiar to y'all? Graph set. Now, we'll take you back. Y'all remember these graph sets or flow charts that I gave you first station? This shows you, it gives you a step-by-step flow of how the PLC program runs on that station. Did you get one of them bigger for the station one? Okay, you say it, right? Yeah. So look, the first, matter of fact, what I'll do, I'm going to shoot that screen. Does everybody have graph set? Yeah. I'll take this right here. And what I'll do is I'm going to pull up that graph set, and I can rotate back and forth between the logic and the graph set. So let me pull up the now, so there you go. You got a graph set there for station one. So you see, when you see a block and there's a number in the block, that's the actual step number in the PLC program of wherever you're looking at, okay? This is step 0, step 1, whatever's in the block is a step number that correlates with the PLC program, step 2, 3, and so on, okay? And then here it makes a decision and it branches this way or that way based on the decision and so on. You got step 30 through 32, you know, 20 through 22. So this is a very, very good tool to have to work with the PLC program to figure out where are you with a problem. It'll help you know in the program where to go based on the way the machine looks. How far did it get before it paused and stopped? It's going to help you get in the right area pretty quick. Okay, so I'm going to flip. Let's go. Let me share that just a second. Whoever may be watching recording, this is a graph set, and it gives you a flow chart appearance. What we in the US we call it a flow chart. The French call it a graph set, and this system was built in Spain, and they're using a French term called graph set, but it means flow chart in US. And so it shows a graphic flow chart way that the actual PLC runs on that one station. That is literally the way that program flows and how decisions are made in that logic. So let me go back to back to the program to there. And does everybody see? Well, first of all, look. What you're viewing right now is you're viewing an offline copy of that program. You're not really viewing it online as the machine runs yet. So on your hard drive, you've got a copy of the program, and that's what you're viewing, what come off of the hard drive on your laptop. Now, the way I know that is over here where it says offline, it says that we're offline and there's no green lights over here. So that means that we're just viewing the offline copy off of the hard drive. So what we want to do is go online and view this as it runs and as it steps through and see it step through the sequence. So the way you do it is like this. You go into communications and you hit who active. You go communications up here and you hit who active. And then it should populate the list of IP addresses like that. Once you see that, if you'll raise your hand, please. Y'all see it? Okay, now. So it went on ahead and highlighted the .1 because it knows I've got station 1 program, I'm viewing it. So it's assuming I want to go online to the IP address of the 130.130.1. So it highlighted that one. Is that what it did on yours? So it highlighted that already. Now you want to be careful over here. Don't hit upload and don't hit download. Don't ever do that unless you check with me first. We're going to just say go online. Now, the other day with Butterball, I had a guy that downloaded the program, and listen, this fella downloaded, look, he downloaded station 3 program and put it in station 2 and locked them up. It's okay, I can laugh about it because I got backed up copies. But if you're not careful, you can really lock one of these things up. It's nothing we can't get out of, but don't ever hit upload and download unless you ask me what you do. Okay, and then we'll discuss it. Okay. Downloading is when you're going to put a copy from your laptop down into the PLC. That's a serious thing. Uploading is going to be to get a copy of the PLC back up to you. If you don't have a copy, maybe you have the current copy in there. Uploading is getting in front of that PLC up to you. You're here, the PLC is down here. So downloading is going to put a copy from you to it. Uploading is a copy from the PLC up to you. We're not going to go either one right now, unless we have to, okay? The only reason you would have to do it is if there's been a change on one of them that I've had to do, and then maybe you don't have it on your laptop. So we simply go to where it says go online. Go online over here. Right over there, go online. And if you watch, you should see some green lights pop up over here, and it'll say you're in run mode, and it'll say remote run and all that. Do you see those green lights over there? Everybody sees it. Very good. So now over here you see green highlighted. There's a latch instruction. How many of you have had a PLC class where you know what L means and you know what U means? What does L and U mean? latch and unlatch. Those of you that have had ELC 128 that have written those programs, you know that it means a latch. Now, the guy that wrote this, the programming in Spain, he loves latch and unlatch. This guy, that's his style. He's a latch man, I'm telling you. He latches and unlatches everything in the world in it. That's just the way he does his stuff. I don't think he wants to put holding contacts in there, but he loves latch, I'm telling you, man. Hey, whatever his name is, his middle name is Latch. I mean, that's what like Ricardo, Latch, whatever. Okay, he's in Spain. So I'm just kidding. Anyway, so look, when you see something in green, that means that it's on, it's energized. Okay, like this particular address is energized, and these other ones are not. Okay, so now what we're going to do is it's already at step 0 in the graph set. You notice it said first step of the graph set. See, it's telling you it's relating itself to the graph set, isn't it? Okay, so that's something you need to remember. It's important. My mask. I'm trying to put it on my chin where I can talk and not sound like a muffle over here. So it's already at step 0. Now we want to go to step 1. So let me kind of go over some. Step one is called feeding cylinder forward. Okay, and that's step 1 in the graph set. Now you got to have, for that to happen, you've got to have all green lights on this line or all green lights on that line, one or the other. Okay, and so first of all, you got to have a pallet presence on the belt, on the conveyor belt. There's got to be a pallet there. Okay, and that's one of the first things that has to happen. So watch closely. As we put a pallet on there, you have to manually put one on here. We don't have a robot doing it. Watch the screen for pallet presence. You see it come on? Now watch closely. I'm going to push the pallet back away from the limit switch, and you'll see that input go off. See it go off? Now, look, I'm going to let go of it. There's a little micro switch down here, a little rocker switch to get ready to make right now. So up under the pallet, there's a little micro switch with a roller, and it feeds an input. This is an input on the remote I/O. Anything that says pallet control on the address, instead of saying local, like this says local body presence, this is a sensor that senses the body. It's a proximity sensor here. This address says local, which means that sensor feeds the front section where the CPU is. It's in the main body of the ELC. Any other address, like when it says pallet control, that's going to be the remote I/O in the back of the pallet control. Now, so what's missing now is a signal for us to continue. Now that signal there comes from another line that works with the start button. So what I'm going to do is I'm going to hit the start button, and you'll see it execute step 1. So watch the line. Actually, look, if you take a look on the machine, I want you to see the cylinder go forward, and I'm going to leave it right there. I want you to see the cylinder go forward and then look at the screen. Okay, so watch over here first. You ready? You see the cylinder go forward. It went forward. Now let's take a look. Feeding cylinder forward, step 1. So that's where it's at right now. If you put the machine in manual and you step it through if you hit the start button one time, it jumps to step 1 and complete. And then you hit start again to jump to step 2 and complete. And so on. So you can step the program through for diagnosing problems. So if we go on through here now, look, we're at step 1, and then step 2 is called position verification cylinder downwards, step 2. And what that does is this.
there's a cylinder over here that it goes down. It's got a rubber plunger in it. And what the plunger does is that rubber plunger sees, can it get inside of that body and that board where it's been bored out to hold the bearing. So if that plunger can get down inside that board, it knows that it's positioned correctly. If somebody puts it in upside down in the hopper, that plunger it would deadhead on the block and it can't get down in the board. And then it knows, because there's a sensor on here, it knows that the body is upside down. And it will, when it gets over to the next station, it's going to kick it down the ramp if it's upside down. So this is where it checks to see if the body is positioned correctly as far as upside down or not. Okay. So you're going to see this cylinder go down. You'll be able to see a light come on that says that it made it all the way down in there. Okay. So I'm going to hit the start button. You ready? The cylinder's going to go down. The cylinder went down. And you see it happen on the screen. See that? Now, while we're at that, for that to happen, one of the preceding things would have been the feeding cylinder forward section had to be on, the F1 section had to be on. That's the section that's on the cylinder itself, the settings forward. If that had not been on, it would have been straight forward. You've got to remember that everything on that line's got to be green for that output to come on. And if you're missing one thing on that line, it'll never go green. Now, once everything on the line is green, it's going to latch the instruction. Once it's latched, it doesn't care if anything, if you lose any signals in here. Because, you know, a latch instruction, it only needs one impulse, one trigger of a latch instruction, and it stays latched on. And from that point, it stays latched on, even though you lose some of these inputs. And what will make it actually unlatched will be something on this line to trigger a new unlatch that will make this clear. And the way they step through the program is like this. It's very straightforward if you look. When they step through, here's how they go from one step to another. Step through the latch on like that. That's the take your address and latch on. And when I go through and I hit the start button again to make sure it's free, when step 3 latches on, step 3 will come back here and unlatch step 2. See that? So when step 3 comes on, that same bit, that same internal bit program, step 3 is the internal bit program. It will come right back here through this contact, which will unlatch this step and clear it with the green number. So every time they step to another line, that step will unlatch the previous step. And then when it goes to the next one, then that will unlatch the previous one. That's the pattern of how the guy wrote the logic. And so if you step on down, the next step is position verification cylinder will go up. So you ready? I'm going to hit the button again. And you'll see the cylinder, you'll see it go up here. So it went up, and then, so we're at step 3 right now. And you notice that when step 3 come on, this here came on and it unlatched step 2. So step 2 is not latched anymore. So that's how they do their, you know, this step came back, triggered on here, and it unlatched the L and the U here. When you latch a step on, the L and the U are lit at the same time. And when you unlatch it and you energize the contact on the unlatched line, it will turn both of these off. So the reason why the L and the U are lit at the same time is because they're the same address. They're reflecting the state of the same address in there, that address is on or has a 1 in it. So the cylinder's up, and the next step is your feeding cylinder is going to go backwards. And the feeding cylinder is the one that brought the block in. It's just getting ready to come home. Okay, 1, 2, 3, it's going to go home now. So it came home, and then the bodies fell in the hopper, and then we step on.
The next step is the transfer cylinder will go forward, step 5. Now again, the conditions right now for that to happen are ready. One of the conditions for the transfer to go forward is that the feeding cylinder went backwards. The feeding cylinder backwards is a sensor. F0 is a sensor. You can look under the schematics. It's online now. When I hit start button, the trigger this, it will go ahead and bring that cylinder forward. But if the feeding cylinder had not come home, that wouldn't be on. It would never let the transfer go forward. So what are we saying here? If this had never gone home, this would not be on. If it got jammed up or something, if it didn't make it home, if that was not on, it would not let this go out because it would produce a jam, right? If this one didn't come home and that one tried to go forward, it would be a lockup, right? It wants to know this one is out of the way before it's going to bring that one forward. So it checks to see, is the way clear? That makes sense? Okay, so it's got that type of checks in there that it checks things with the sensors of the eyeballs of the PLC. That's how it sees where things are. It's by way of these sensors. That's how it knows where things are. Is it safe to go do that next move? And it knows it by way of these inputs. Okay, and the inputs is something I'm going to be playing around with when I put problems in here, where I'm going to have something where something's not going to be on. Okay, I want you to see how to trace the program before I start putting problems in there. I want you to see how to get all the way through one of them on your own. And so now I'm going to hit the start button again, and you'll see that transfer cylinder coming forward across this way. So if you look at on the machine, it's going to come this way and bring it across. And you see how it was active there. So it came across. And then the next thing the transfer cylinder will go backwards. That same cylinder is going to go home. So it went home. Okay? The next step is where you have the rejection cylinder will go forward. If the part was in there upside down, it's getting ready to kick it out, but it's not going to do it now. Look, let's go to the graph set. I'm going to show you where decisions being made right now in the graph set, and you'll understand where we are at the crossroads. So let's change. Let's go back to the graph set. If you look up here, the body transfer cylinder did go backwards at step 6, right? So now it's going to make a decision at this point. And the decision is going to be this. Let's go a little bigger. So at this point, it can either go to step 7 and reject, and the reject cylinder will kick it down the ramp. If you look over here on the machine, the block is sitting here at the ramp. That little short cylinder can kick it down the ramp and get rid of it. It can. It will get rid of it if back here, if this cylinder said it was upside down. And it will remember it over here to kick it down the ramp if it's flipped upside down. But if it's not flipped upside down, it won't kick it out. It's going to go to the other fork in the road, which would be step 9. So look, the decision here is this. Here it says, if the body is okay, it goes to step 9. If the body is okay with a bar over it, the bar over it means it's not okay. So if you see some word that says body okay with a line on top, it means not. It's not logic, not. So body okay, not, or body okay. So if the body is okay, if it's oriented right, it's going to go to step 9, and the insertion manipulator will come down with the suction cups and get it. If the body was flipped upside down, body okay, not, it would reject it, and then the reject cylinder would go forward, and then it would go backwards, and then it would cycle back around and go up, back up to the top again, and it would actually try to feed another body forward. It would actually cycle back around and start the process again to get another body that's oriented correctly, okay? That makes sense? So it cycles back around if it was wrong. But here you're not going to see 7 or 8 activate. It's going to go to 9. That's why I'm going to show you. It'll skip 7 and 8. It's going to go to 9. So if we go back to our program, to our logic, 7, it will skip 7, it will skip 8, and it's going to go straight to 9. Now you watch, you won't see 8 light up, but you're going to see 9 come on.
And that's where the insertion manipulator with the suction cup is going to come right down again. I'm going to hit it again. So it came down. Y'all want to look up here and see the insertion manipulator come down with the suction cup and it's down on top of the block now.
You see 9 lit up. So 9 lights up on the graph set is going to the right on the graph set. Everybody understand? So what's next after the insertion manipulator down is it says what? It's going to turn some vacuum on in the suction cups.
So if you listen closer, you hear noise, and then it picks it up. So it does 2 things in one step. It turns the vacuum on, and then it moves right over to the next step and brings it up.
It turned it on, it went on, and it did it brought the manipulator upward, and it unlatched 10. 10 happened so fast, and it got to 11. 11 went back and unlatched 10, so you didn't even see 10 light up. It was so fast. But it did do it. It turned the vacuum on, and then when it went to 11, it come up. 11 went back and unlatched 10. That's why you don't see 10 lit up right now. So it clears the previous step once it does it. So the manipulator came up, and it's got the part by vacuum on those cups. And then what's the next step? Insertion manipulator forward. Now look.
So this is your double rod cylinder right here. Your double rod cylinder will be told to go forward like this. But what's making all these moves is you've got solenoids, air solenoids that are being sent over to the PLC. Those solenoids in that plant there, the solenoids make air move, and that's what moves everything. The solenoid makes, okay? That are sandwiched on these map cards. So it's getting ready to go forward. And if you watch, you'll see step 12 light up. It just here moves. So watch the machine. And there it goes. So it went forward and 12 lit up to that. There's sensors on the cylinders over here that you can see that it's in here lit up. Depending on where you are, you'll see some of the sensors, some of them you won't. But for every move that it does, there'll be a sensor right there that tells you that it's actually got to where it was going.
So for instance,
when that went forward, when it went forward, this sensor here, this first manipulated forward, there's an 81 sensor that actually lit up. You guys look, there's this here says 81, you see it lit. The 81 sensor is lit, which confirms that it made it completely to the inner stroke. It's already out there completely, lined up properly over those pins on that pallet so it's safe to bring it down. So this sensor is confirming that thing stroked completely out. And now it's okay for the other cylinder out here to bring it down, the one that's tied to the end of these rods. Okay, everybody see? Or not? This, okay, so it went forward here. And then when it made it forward, this sensor, it says 81, that sensor came on, that's going to let it come down when I hit the start button. That right there, that comes to the start button. I'll hit this, it's going to come down, and it went down. So step 13, we're on step 13 right now. So it went down, and then look, with the B1 sensor that came on, that proved that it went down. You look out here on the end of it, you see some sensors out here, that bottom one says B1, don't it? B1. So on the bottom of this cylinder here, there's a B1, there's a B0 up top sensor. The B1 sensor is on, which says that this stroke all the way down, it made it to the bottom stroke of that cylinder. So B1 come on. Now, if that sensor had not made it on, that means that the cylinder didn't make it all the way down. So it wouldn't turn the vacuum off. You have to stop the vacuum and cut it. It knows it's all the way down. It's going to cut the vacuum off now. Ready? Here we go. So it cut the vacuum off.
And then the next step will be the insertion manipulator will go up because it turned the vacuum off.
Now it's released it. Now it's time for it to come back up. Now I'll show you something here that you're going to see.
Now, watch closely here.
When I hit start button, it's going to trigger this. You can see step 15 coming on. The manipulator will start to go up. And when it gets up, the B0 sensor will come on, saying that the insertion manipulator is up. So that B0 is the top sensor. It's top sensor up here. Right now it ain't on. B0 ain't on. B1's on. But when you see it come up, you watch on that screen and you'll see that B0 light up that says it's all the way up. And it made it up, right? It sees it made it up.
So watch carefully. So at the same time, when you see this happen, shortly after, that sensor will be on that says that it actually did get up, and then it's safe for the manipulator to actually come back and travel back because it knows it's up.
So I'm going to hit the button for it to come up. When I hit this, you will shortly after see the B0 come on. So you ready? And then see that was a delay behind it. When it started coming up, it took a little time to get up. And when it got up, that sensor there made the B0's on, which is up top. And that proved that it got up. And so the reason why it's checking that, it wants to make sure it's up so it's safe to bring it home. Because if this thing was down and this cylinder came back, it would actually rip the cups off. So it has to be completely up and clear before it can come back this way. So every move it makes, it's going to make sure, you've got a cylinder attached to another double rod cylinder out here, and it gets out there, it goes down. Well, it's got to come all the way up before it can come home. And the only way it knows it is by way of these sensors, okay? That's the kind of stuff you're going to be looking for when the machine is not doing right is, could there be a sensor that's not on? Is that the reason why it got halfway through the sequence and just sits there like a power button? Those are some of the things you'll be looking for. What is it that's not, when it got to a certain place, why is it just sitting there? Why didn't it go ahead and finish? So you're going to be looking for things like that are not satisfied.
So if we go next step, the manipulator is going to come back, and at the same time, it let go of the pack. If you go back to the graph set, that was at step 16. Go back to the graph set, and you'll see that we're at the end of that cycle. You get down to the end of it, and what does it say? The insertion manipulator comes backwards, and then the stopper goes down. When the stopper goes down, the stopper is the thing on the belt. When the stopper goes down, it lets the pallet go. That's your pallet stopper there. So this thing come back, the stopper went down, and it let it go, and that cycle is complete. Everybody follow? So this was some good timing. It was great. Y'all did good. What you want to do now is exit out of all software. Don't close the lid. Don't put them in the bag with the power on. Some people do that. They just close them up, put them up. You can crash a hard drive doing that, okay? I want you to exit all the way out of the software, shut it down normally, shut the whole computer down. Don't move it till it's shut down, all the way down. Don't move it around because it's got a hard drive in there. It ain't like one of these new ones that's got solid state drive. It's got a magnetic drive in it that if you move it when it's running, it may crash it, okay? You can go offline. Yep.
I got an issue. So it says D3 popped up on my computer.
computer a second ago, and it said, we'll cut off for 1 minute, it cut off.
So it shut off, it shut the computer off. So was your battery, was your power supply plugged in?
Yeah, it had power. That wasn't a problem.
Everything was plugged up, and it said, D3 will shut off in 1 minute.
Okay, I'm not sure why it did that.
I had an X on it, I figured I wasn't moving the mouse around. It X on that. And then a minute later, cut off.
It's okay. So look, it powered down all the way down by itself. So it's okay. You go ahead and put it up. Yeah, I'm glad you let me know. I'm not sure why it did that. That ain't the first time I've seen that happen, but I know I'll have to ask the IT department. The IT department has got some stuff going on with these that I'll have to just talk to them about. Yeah. Okay, I'm going to end the session here. Whoever may be watching, McGill and whoever's watching, if hopefully you can come and be here Thursday night. And thanks for watching. Have a blessed evening.